My name is Jim Vajda. I'm the Chief Wireless Officer here at 7SIGNAL. And what I'm going to get into is some real use cases, some customer stories, and a live demo of both Mobileye and Sapphire. And for us, healthcare is a big industry. Kaiser Permanente is a big customer of ours, and of course, we all know about how important Wi-Fi is in healthcare, and the client challenges in healthcare are huge because there's so much mobility, there's legacy devices, and it's difficult to make all that work together. In the healthcare sector, a lot of customers are getting a lot of value out of Mobileye, and I'm going to shift here and jump into a demo. All right, so this is the web interface for Mobileye, and this is what administrators see when they're troubleshooting and running reports and things like that. Like Simon mentioned, our agent is running in the background without a UI on the endpoints, just collecting data to send to the cloud for analysis. And we're looking at the page of a single Windows machine here. This is in our demo environment. And for troubleshooting device issues, particularly in healthcare, roaming is a big issue, right? And it's very difficult to understand the roaming performance of a workstation on wheels or another, maybe an Android handset in a hospital. The help desk tickets that get registered probably don't mention roaming. They probably say there's a coverage hole somewhere because the end user saw the signal strength indicator go down. And trying to recreate that problem can be really difficult because maybe that workstation on wheels is 3 floors away, and you don't even know what machine it was. So this is really helpful, and you can see right here on the interface on the left-hand side, we're doing an automated problem analysis from all this client-side data and identifying if certain Wi-Fi issues are happening. Right on top, we can see roaming issues are occurring. And I can drill into this timeline for this particular machine and look at all the data that went into determining the roaming problem here. So very simple, right? Signal strength below the threshold we want it to be at, minus 72 dBm. It's probably not a great RSSI if we're doing, VDI or voice on this device. And from the device's own channel scan results, we've identified a roaming candidate, another AP that's there providing coverage with a much better signal strength, minus 53 dBm in this case.
So what's wrong?
Sorry?
So what's wrong? Why is the device not roaming?
Yeah, good question, right? So there's a couple reasons for that. First, it's really valuable just to figure out which devices are roaming well and which aren't, right? So you can start, figuring out, who are the rotten apples, right? Is it a certain kind of laptops, or a certain kind of handset, and what are the characteristics of that are causing issues? A couple things that, we see being very impactful are the wireless adapters and drivers they're running, right? So that's something we're collecting with our agent here as well. So we can see, if there's an adapter that's having, a significant issue with roaming, or a driver version that's associated with that adapter, where more roaming issues are occurring than with other machines. So we can get down to some root causes there.
And so you're looking at the entire set of clients across all of your customers to establish those patterns?
What you see here is just the data from your own organization.
Okay.
We'll talk later on about, some global analyses, that we're investigating.
You could try to detect and say, okay, this driver is not roaming properly across many organizations, so I could flag it as maybe you should upgrade type of device.
Yeah, and what we find is that there's usually, just a pretty strong signal just within your own organization to see what those versions are, without needing to look at other data sets. There's also, the issue of, is it just roaming poorly in this network with these APs and the code they're running and the way they're configured, right? So that plays a role too.
Are you setting those thresholds at an organization level, or is that happening either per floor or per device?
It's set at an organization level.
Are you able to map this to location, like where the user is and how they're moving through the building?
Yeah, so yes. So, and the way we do that is by, usually the easiest way is just looking at the name of the access point they're connected to. And in a lot of organizations, that's got, a floor and a area or a building in it. But we also have a location feature where you can upload all the BSS IDs or the base radio Mcs for a location into Mobileye, and then the location field will be populated with that down here. Yeah. So our headquarters. Bad roaming there.
Okay, so I can find my location by saying I'm within this cell, but and then I can see if I can see other access points. So I could potentially triangulate it a little bit.
Yeah, you could. I mean, you could infer its location from there. We're not doing real-time location services or anything like that, but you can certainly figure out where it is.
Where they had the problem, where the roaming problem occurred.
Yeah.
Okay.
Is that headquarters from the name of the AP in the description field?
No, that's something that we create. So locations for us are just groups of access points. So you can get an export from your network management system with the base radio Mcs or BSS IDs for a site. It could be a building, could just be a floor, and create that location from that group.
Could you use the AP name instead?
The AP name is always available, and our agent will grab that out of the beacon frame from the connected APs too. Yeah.
So perhaps I'll jump in.
Yeah.
So when we talk about our locations feature, it's actually locations and AP names. So we create a hierarchy in the system from the BSS IDs that what the clients will see. Sometimes they'll see an AP name broadcast. A lot of customers don't broadcast AP names or don't broadcast them on all BSS IDs. So we create a relationship between the BSS IDs or the base Mcs and the access point, and then between the access point and the location. So it's effectively a hierarchical group.
Right. So we know that roaming problems are really hard to troubleshoot and identify, and this really reduces the mean time to resolution for those. It also helps out with mean time to innocence, because if your responsibility is just the Wi-Fi infrastructure, roaming problems keep landing on your desk, and you really need whoever owns those devices to take some intervention to help fix the overall performance over the air. And the other analysis we're doing is looking for coverage problems. Using the same Wi-Fi scan results, we're differentiating from if there's a roaming candidate AP available or not. Right? We can really say yes or no, there wasn't a coverage issue. Congestion, we're going to pull the QBSS channel utilization number and look at throughput test results and so forth to determine if there's significant RF congestion. And then we're looking for code channel interference and adjacent channel interference as well to find issues like that. And you can see in the scan results from this machine, we kind of have a big mess down on the left-hand side of the 5 gigahertz band. So, poor channel planning at the headquarters.
So are you able to compare the RSSI level from different type of clients? So you could say, this specific device is worse than the rest, but it's actually, it would be better to actually just change the device versus changing my entire design.
Mm-hmm.
Do you do this type of analysis?
You can. And that's something that's going to turn up as a coverage problem, the way we identify it. But it's really, it's an insensitive client that's resulting in that. And that would stick out in some reports and on the device page here. It'd be easy to see.
Okay.
So one of the things we do with the scan results is we give you this, kind of Wi-Fi scanner, ziggurat's view of the APs in the air. And we do this for all our clients, Windows, Mac OS, Android, Linux, and so forth. But one of my favorite features is I can actually export this as a CSV and take it into Wi-Fi Explorer Pro, and then look at the results here. So, I get channel utilization and station count, and the signal strength and channel, and now I can look at one of the first things I would do in troubleshooting if I was at a site is pull out my Mac and open up Wi-Fi Explorer Pro. But now I can just get the data from that client from the point in time when there was some question about the Wi-Fi network, and use this tool to analyze it then.
Could you just do that again?
Yeah, sure.
Bada bing, boom, there
Yeah.
you go. Seeing data.
Yeah, so just from our interface, we're presenting all the Wi-Fi scan results, and you can browse through them over time, right? Each one has a little timestamp from when it was gathered. So I can go back up to 90 days from any device here and hit the CSV button to export that, which just gives me a CSV that's downloaded locally onto my machine. And then, Adrian, super gracious and built support for our export. So I can just take the file, just like you could do with a packet capture, and drop it into Wi-Fi Explorer Pro and get that point in time here.
Do you mind opening the CSV?
No.
Thank you.
So
I was wondering, how does that work? Do you see different clients reporting different type of information? Not scanning the same channels, or?
Yeah, that's an interesting issue, isn't it? Because if a client doesn't support all the 5 gigahertz channels, then you wouldn't see those APs that are there that client may not support. But yeah, it's pretty straightforward. BSSIDs, the SSID, RSSI, and so forth.
And all client drivers will provide this type of information?
Yeah, we're getting, there are some limitations with certain versions of Android, but we still get
Older versions, particularly.
we get scan results from Android handsets.
There's permissions on both Mac and Android, permissions requirements to get access to that data, but it's all available.
Yeah.
Why not just present that data in the dashboard?
Yeah, it's a small part here, and that's what you're seeing here. And just, because there's so much we want to show,
Yeah.
It's a small area, but we've got some ideas about
Not to
enhancing.
discourage people from not getting Wi-Fi Explorer, but
Mhm.
just in case people don't have that ability, it seems like someone might say, "Oh, I need to get another app that's not yours in order to see this data."
Yeah.
This doesn't include the beacons or any of the frame components that you would normally see on Wi-Fi Explorer. It's just straight CSV text value go.
That's correct.
Okay.
Yeah.
So the advanced details isn't.
Right.
Yeah, it's not going to be. It's not. We're not doing a packet capture. We're
But
getting.
still, yeah.
Yeah, we're getting what we can get from the operating system directly.
I'm glad you showed me. I thought it was magic first, and now it just looks like magic.
Yeah.
So that information is on the operating system on the scan gun.
Mhm.
There's no data there whatsoever. Right?
Yeah, so there's just a little bit of data around like the channel utilization and station count that comes from the QBSS information element. All the major operating systems can grab that now. So you get, enough to be dangerous.
And it overwrites after 90 days? Or
Yeah, it dumps, the oldest and writes.
Sliding window.
Yeah, sliding window, thanks.
So how big is the data file? If I wanted to upload for, let's say, 10 clients, they had a problem and it's somewhere about an hour.
Mm-hmm.
What sort of size file would be, how much data would that be to run over the wireless network?
Pretty small, right? So the agents collecting information usually directly from the operating system in the case of the Wi-Fi analysis, and just uploading. How big is the payload? It's kilobits?
Yeah, kilobits.
Yeah.
Oh, yeah.
Kilobytes, a small amount of data.
How frequently does that happen?
So there's two things, and that's a good transition, because the other thing Mobileye does is active testing. Passive testing is what we just saw, getting scan results and data rates and so forth, just by asking the operating systems for those pieces of information. Active testing is when we go and do a ping, a throughput, a web download, or a VoIP test. And we're creating real traffic and measuring that performance. So we control those intervals separately. The active testing window, I think by default, is 15 minutes. And the passive testing window is 5 minutes.
Yeah, and working towards less for certain data.
Right.
Thanks.
So it's like a periodic sampling, right?
Who are the typical users that are logging into this and looking at this data? Are they mostly Wi-Fi knowledgeable people, or are they help desk type?
Good question. It's really both.
Okay.
I mean, network engineers predominantly, but in many cases, it's operations teams that are using this, and help desks as well, definitely.
I'm just curious of the workflow. If I was to log in and I see this, I see red under roaming, but coverage is good. Congestion is no congestion, but yellow and interference. Like, how do you drive someone to determine what the exact root cause is and what actions they need to take from there?
Yeah, good question. So for help desks, one of the things we developed was a troubleshooting guide on the right here. So for those end users that see red and have never heard of roaming, what are some, first call, very simple interventions that might help, right? Toggle the wireless adapter, look for a driver update in the case of Windows, those sort of things. And then, you build a playbook where the help desk says, okay, if there's coverage, if we see coverage, I know escalate that to the network team. You see roaming for a certain device, perhaps escalate that to this team, and so forth. So
that's what I'm trying to mitigate is I see red, I'm gonna escalate this.
Yes.
To the network team.
And that's why help desks are getting trained in using this. So they're not immediately, hearing Wi-Fi and sending something up, escalating something that isn't a Wi-Fi issue. Well, that's a big use case here, is actually coming in here and finding no Wi-Fi problems, right? And saying, okay, you're on the phone, you told me it was a Wi-Fi issue, but maybe I'm not seeing an issue, and we can look at some other areas. One of the things we're just getting started with is system resources, right? Is the CPU pegged because there's some out of control process that's doing that, and that's resulting in really bad Teams or Zoom performance, for example. So getting a little broader there. Okay, I think we should move on. One of the really interesting things to me that we've started doing is really embracing the Mcs Index And thank you, Keith. You know, that was feedback Keith gave us. And I want to just talk about what we're doing there. You know, one of the challenges we have in wireless networking is like, how do we just summarize the Wi-Fi health for a single machine? And a lot of the solutions out there give me things, in my opinion, that it's hard to really attach meaning to. So, for example, a Wi-Fi health score that's scored from 0 to 100. I don't know what that means. I mean, if it's 100, I assume that's really good and everything should work. But if it's in between somewhere, is that good? What do I need for voice on this device in this network, for example? What I want to know is, are the design criteria I have, are they being met? And do we have the SNR, and is packet loss, latency, and throughput acceptable? And on down the list of design requirements. And so there's a challenge there because validating all that isn't as simple as giving a simple health score. So something that we've been using and talking about a lot is the Mcs Index. So it's closely related to data rates, but actually it's a simpler idea. It's only, MCS is the modulation encoding scheme. So we're only concerned with the modulation that's being used by the Wi-Fi device and the coding that's being used for that. And we're really interested in the modulation specifically. So if you take those things and add a channel width and a guard interval, you can get a data rate. But when we're thinking about link quality and the quality of a Wi-Fi connection, if there was only one thing I could use, I'd like to use a few things, but if there was only one, I'd probably first look at the MCS that device is using. So the MCS is going to be it sort of arises out of a natural process of the Wi-Fi device data rate shifting. It's going to try a number of different data rates and land on the highest it can kind of sustain without a lot of retries. It's pretty stable. So I almost think of it like the device is doing its own health check of the Wi-Fi connection it has, and the MCS is kind of a result of that. Additionally, MCS is really gaining importance and is more valuable than data rates in Wi-Fi 6, because in Wi-Fi 6 now we've got really, really narrow resource units. So we could be up at MCS 10 or 11 with 1024 QAM, but if we were allocated a very narrow resource unit, our data rate might be less than 20 megabits per second. So the old way of thinking about, the data rate's low, so connection quality is poor, actually doesn't work so well anymore in Wi-Fi 6. And it's easier just to simplify it. Let's forget about the width of the channel and the resource unit and look at the modulation from the MCS. So that's what we've begun to do. So a challenge with that is that Windows and other operating systems don't natively report the MCS they're using. And so we've had to reverse engineer that. And in some cases, there's ambiguity. Is it 6 or 7? Without knowing the guard interval, sometimes you don't know. So we just kind of simplify that. We say that's 6.5, right? And probably you don't care if it's 6 or 7, but knowing it's one of those two is going to be valuable.
That's what you call the 7 MCS?
Yeah, that's where 7 MCS comes from. The other thing it does is it standardizes the MCS across PHYs. So the old days of 802.11n with MCS up to 32 or wherever it went, we take those values and convert them to the standard, the spatial stream independent MCS index from 802.11ac and AX. So that gives you the ability to compare performance of different device types and devices across different generations of Wi-Fi to have a look at their quality. And this is in Mobileye now. So pretty cool.
So how did you reverse engineer the Windows MCS? Which data are you using? The data rate?
We're using, yes. So we're using the phi in use is NACAX, the spatial streams, the active connection channel width, and the data rate.
So you're getting all of that data from the client?
Yes.
Okay.
Mm-hmm. So I'm going to shift and start talking about Sapphire and jump into a live demo of that. So that's again the sensor. It's really useful in healthcare environments. It complements Mobileye really well, and it's also, among other places, really useful in large public venues. Madison Square Garden being an important customer for us. Yeah.
Sounded like, there's, I know clients vary a lot, right? So when you're installing the agent on different devices, how similar is that data that you're getting back? I would imagine a lot of it's going to be the same, but are there like fields you're not getting back from certain types of clients? And
we've done a lot of work to make sure we have parity between the operating systems. There are differences, like Mac OS will just give us its MCS value, so we don't have to reverse engineer it. And Windows, we have to jump through some hoops to figure it out.
Yes, SNR on Mac as well. You don't get that anywhere else.
iOS, you can't get anything super useful, right?
Yeah, we don't even have it. We don't even support iOS for Mobileye, right?
Yeah.
Because it's too locked down.
Do you guys try to work with the manufacturers to talk to them and get some sort of VIP treatment?
We haven't done that yet. There are some opportunities there, but right now, we get enough to work with, and vendor neutrality is one of our, something that we value too. So not yet. Jumping into Sapphire, one of the things that we're not yet doing in Mobileye is measuring the connection setup, authentication and association, and EAP performance, and so forth. And so Sapphire is actually a really nice complement because the sensor acts as a early warning system. 24/7, it's checking, am I hearing beacons when I expect to hear them? Or is there a stuck radio, or it's, the RF environment's so bad that I can't receive all the beacons that I expect to. And we go right through the whole setup process. So is association working? Before that is 802.11 authentication working? If we were doing EAP authentication, we test each phase of that to make sure it all worked. And then continuing on to test the required network services for Wi-Fi, DHCP and DNS, ping, and application layer testing, doing throughput and VoIP testing as well. That's the active testing part of Sapphire. It's kind of what sensors are known for. But to me, I think what really makes them valuable is the what we call the passive testing, where we're almost doing like an automated protocol analysis. So this is where we're just putting the radios in monitor mode and observing the natural Wi-Fi traffic that's occurring in the network. And so, large public venues where they have that big game or that big concert, and they hope the design works, there's a lot of assumptions that go into capacity planning and the RF design in those environments. And, it's when the event happens is when the rubber meets the road. So really valuable to have Sapphire deployed in those environments because then you're observing and collecting a huge amount of data about the traffic that was occurring during that event. So then you can go back and do some, postmortems on how things went. Did the network perform the way you expect it to, or were things not so great? So, and we're looking at a lot of different data, but retry rates. We have an airtime utilization calculation that we do, and you can get fairly granular with that. So you can see, was management traffic a big part of that? Was data traffic a big part of that? Was control traffic? And then, particularly in a large public venue setting, probing behavior. Like when everybody showed up and their phones started probing, how bad was it?
Can I just make sure I understand this? So
Yes.
public venue, the software is not going to be on the majority of devices, right?
Yeah.
So what you're suggesting here is a handful of devices kind of distributed around the sports venue,
Yeah,
then would capture this information, analyze it?
exactly.
Is that what you're saying?
That's what our Sapphire sensor is. It's actually hardware that gets mounted under seats or in other areas where it can monitor the traffic.
And what's the difference between doing it on the client versus just doing it on the access point?
Right. So the benefit here is this is never transmitting. So it's not when it's doing its passive testing. It's not sharing or dealing with the challenges of being very close to another transmitter, maybe in the same enclosure. But also, this is doing a level of analysis, like an automated protocol analysis to give you data that allows you to get to those root causes of performance problems pretty quickly. So
I'm just not quite sure why it would be different from having an access point in sensor mode. The advantage I can see is that you could strategically position them. I could see that,
Yeah.
but I can't see from a data collection perspective it being any different. Am I missing something?
well, I think it's just, I think what we do is a layer of analysis on top of that. So, sensor mode APs are good, but, this is, we're creating over 600 different metrics from the analysis we do that allows for some deeper integration. And we also have spectrum analysis that goes on too.
To better understand your graph as well. So what we see here is like an event happening, I guess. So like when the probe response channel utilization goes down or up, I don't know really here. But so this is when the people are coming in the venue. That's what we're looking at right now.
Well, yeah, actually, you'd probably expect to see the opposite, in a large public venue. This is our demo environment, so it's not.
Okay, it's not like a real event.
Right.
Okay.
Right. But one of the issues in large public venues is, as soon as when everybody shows up, their phones start probing, and that really can chew up airtime. And all the APs that hear those probe requests will send a probe response, and that can really chew up airtime. So we're relying on features from AP vendors to suppress probe responses for in the event that the incoming probe request is below an RSSI threshold or something like that. So this really helps kind of figure out, is that feature working, and do I need to adjust it and tune it? And of course, client behavior is changing all the time. That's a entirely BYOD environment. And so what comes in for one event might be different for the next event. And so you see differences there.
Is this data also capturing on different channels? I couldn't tell here.
Yeah, it does. So the way that this is aggregated now, we're actually just looking at the 5 gigahertz band. So we're just reporting on a service area, but I could break it up and look at each of the APs and so forth.
So they just rotate and scan all the channels? Okay.
Yeah.
In it, this is kind of a two-part question. In LPV or in the carpet areas, what's the ratio of Sapphire Eyes to APs that you recommend? I know it depends is the first answer, but in general.
Thanks, Sam. In carpeted office, it's 4 to 6 access points per Sapphire Eye. In LPV, we need to help with the design and just figure that out. It's sometimes 8 to 10, but it's variable. Yeah. Yeah.
Are there any limitations to the deeper frame data that you're getting in environments where like MFP is enabled or WPA3 is going to be enabled?
Yeah, in some cases, right? Because we're not decrypting anything. So, you know, if it's a clear text in the layer 2 header, you know, we can work with it. If it's not, then that sometimes means there's some data we can't see. Yeah. Yeah.
So I've been following you guys for a long time, right? We were talking about it last night. I know that there was like a whole, so you had your KPIs. There used to be like a whole board of like KPIs that we could follow and tune and that kind of stuff. And then I guess one is that I'm assuming that's there in some fashion. I think you got the calling out the KPIs and you alluded to it already. So.
Yeah, that's our SLA report, right? So this is the reporting side of Sapphire Eye, where you can get this report generated automatically and sent to you. So, you know, you don't have to come into the interface to see what's going on. You can get a scheduled report based on, you know, the Wi-Fi SLAs that you can define. So you can say, you know, establish an SLA for the most important KPIs that you've got and make sure that we're always reaching that.
And then is the Sapphire Eye, are you guys still doing synthetic testing?
Yes. Mm-hmm. And because we have, you know, total control over it, can do a little bit more than what Mobileye does. And so, you know, it's trade-off, right? You're seeing what a sensor can do, not exactly what one specific client experienced. But that at least tells you the infrastructure is doing what it's expected to do.
So the cycle, if you will, for the Sapphire Eye, I know it used to be like associate to an AP, run a batch of tests, associated to an AP, run a batch of tests, like that kind of thing. Mm-hmm. So is it still doing that? And then like also then like listening on a channel, switching a channel, listening on a channel. It's kind of doing all of that now.
It's doing all of that, right? It's going through that test cycle of testing each of the managed APs that it's configured to, and also doing a passive analysis on the channel to observe the data there. Yeah.
When it cycles through the channels, does it spend equal dwell time in each of those channels as it does cycle, or does it like learn what APs are around it and then bias to spend more time passively listening on those channels?
It spends equal time on the channels of the APs that it's managing, right? So it's I think out of the box, it's only going to do that passive measurement on the channels that the local APs are using, with the exception of spectrum analysis. That's always full band. Yeah.
What does that mean, the APs it's managing? Does that mean?
That's the term we use. It's monitoring the APs. So the nearest APs to a sensor are considered managed, but it just means these are the APs that it's actively going to test, connect to, and run its tests, and do the passive monitoring on those channels.
And do I figure that out, or is that the sensor says anything higher than negative 80?
Well, yeah, exactly. There's a configuration where all the sensors get the APs assigned, and then you can also fine tune it and move APs between sensors and things like that.
What's the data retention on this one?
90 days. 90 days. Spectrum analysis, because it's very storage intensive, is 2 weeks. That's still a lot of spectrum analysis.